Case study: Revolutionizing Cybersecurity, AI-enhanced threat hunting across finance, defense, healthcare, and enterprise sectors. AI-enhanced threat hunting is revolutionizing how organizations protect themselves from cyber threats. This transformative capability leverages artificial intelligence to detect, analyze, and mitigate potential threats in real time. Financial institutions, for instance, implement machine learning algorithms to detect fraudulent activities. Given the sensitive nature of the data they handle, these institutions are frequent targets for cyber attacks. By training machine learning models on historical transaction data, these institutions can identify patterns indicative of fraudulent behavior. What happens when a transaction deviates from a user's typical spending habits or occurs in geographically disparate locations within a short time frame? The AI flags these anomalies, reducing the time required to detect potential fraud, unlike traditional methods that rely heavily on human analysis and are often too slow to prevent losses. The defense sector, particularly the U.S. Department of Defense's Cyber Command, offers another compelling example. The DoD employs AI to enhance its cyber defense capabilities through automated threat detection and response. How do AI systems sift through vast amounts of network traffic data to identify anomalies indicating a cyber attack? These systems use advanced algorithms that learn and adapt over time, improving their detection capabilities and enabling the DoD to mitigate threats before they cause significant damage. In healthcare, AI combats cyber threats targeting patient data. Healthcare organizations increasingly face attacks due to the value of patient information. By leveraging AI, providers can monitor network traffic and electronic health records in real time to detect unusual activities. What should healthcare providers do when AI identifies unauthorized access to patient records or unusual data transfer patterns suggesting data exfiltration? Immediate detection allows swift responses, safeguarding patient data and maintaining trust. In enterprise security, AI-driven threat hunting is indispensable for protecting sensitive corporate information. Large corporations often encounter sophisticated cyber attacks that can go undetected for extended periods. How does AI help bridge this gap? Continuous monitoring of network activity and predictive analytics foresee potential attack vectors. A notable example includes multinational technology corporations using AI to protect intellectual property and trade secrets by analyzing vast data sets, identifying potential threats, and responding in real time to prevent data breaches. Darktrace, a cybersecurity firm, exemplifies AI effectiveness in threat hunting. Employing machine learning algorithms to detect and respond to threats autonomously, Darktrace's AI system mimics the human immune system by identifying and neutralizing threats as they occur. In one instance, how did Darktrace's AI system contribute to mitigating a ransomware attack? Early detection allowed the affected organization to take immediate action, preventing widespread damage. Statistics support the integration of AI in threat hunting. According to a Capgemini Research Institute study, 69% of organizations believe AI is necessary to respond to cyber threats, and 64% report that AI reduces the cost of detecting and responding to breaches by an average of 12%. These figures highlight organizations' growing reliance on AI for enhanced cybersecurity measures and the tangible benefits of cost savings and improved threat detection. AI in threat hunting is rooted in several key technologies, including machine learning, deep learning, and natural language processing. Machine learning algorithms learn from data and improve performance over time without explicit programming. This is invaluable in threat hunting, as models trained on historical data can recognize patterns and detect anomalies indicative of cyber threats. Deep learning, a subset of machine learning, involves neural networks with multiple layers analyzing complex data structures. How does deep learning enhance threat hunting capabilities? By processing vast amounts of unstructured data, such as network logs and user behavior, deep learning models identify potential threats with high accuracy. NLP enables AI systems to understand and analyze human language, vital for threat intelligence. For instance, NLP algorithms can scan online forums for discussions about new vulnerabilities or attack techniques, providing early warnings of potential threats. Despite advancements, challenges such as false positives remain. How can organizations address the issue of false positives, where legitimate activities are incorrectly identified as threats? Continuous refinement and training of AI systems on diverse datasets improve accuracy. Adversaries increasingly leverage AI to develop sophisticated attack methods, evading traditional security measures. To stay ahead, AI systems must continuously evolve. Ethical implications of AI deployment in threat hunting include privacy concerns and potential misuse. Establishing robust governance frameworks and ethical guidelines ensures responsible and transparent AI use. Organizations must also design AI systems to respect user privacy and comply with legal and regulatory requirements. The future of AI in threat hunting looks promising, with emerging trends like explainable AI. XAI aims to make AI systems more transparent and interpretable, providing clear explanations of AI decision-making processes. How can XAI improve collaboration between human analysts and AI systems? By enhancing trust in AI-generated insights, XAI boosts the effectiveness of threat hunting operations. Integration of AI with emerging technologies such as blockchain and the Internet of Things enhances threat hunting capabilities. Blockchain can offer a secure ledger for recording and verifying threat intelligence data, while IoT devices provide valuable data sources for AI systems. The convergence of these technologies creates a robust and resilient cybersecurity ecosystem capable of addressing the evolving threat landscape. In conclusion, AI for threat hunting represents a transformative approach to cybersecurity, offering enhanced capabilities for detecting, analyzing, and mitigating cyber threats. Case studies across finance, defense, healthcare, and enterprise security demonstrate AI's tangible benefits in improving threat detection and response. Real-world examples and supporting statistics underscore AI's critical role in modern cybersecurity strategies. While challenges and ethical considerations remain, ongoing advancements in AI technologies promise a future where AI-driven threat hunting becomes an indispensable tool for safeguarding digital assets and ensuring cybersecurity resilience.